afternoon, everyone, and welcome back to the second part of our event. This morning, we saw presentations on mega trends in the Middle East and North Africa. We talked about digital transformation, the value of digital transformation. We looked at technology as enablers by one network, and a discussion group about shaping the future with the digital supply chain in the region. The next segment of our discussion is going to be more about sustainability. So we have a presentation by Professor Philip Greening. We'll then have a case study on a transformational circular economy business. And then there'll be a panel discussion on sustainability. So to start us off, it gives me great pleasure to introduce Professor Philip Greening. Professor Greening is a director of two research centres at the Heriot-Watt University in Edinburgh, the Centre for Sustainability, Road Freight, and the Centre for Logistics and Sustainability. These two research centres define Philip Greening's research focus. Philip, hi, nice to see you. Thanks for joining us. It's early time in the morning. You're on mute at the moment. It is great to have you with us. Thanks for making the effort to join us. And I know that you've got some very interesting insights, apart from the research you've done, but your views of where we're going and what we're doing is going to be very defining for logistics sector. The keynote speech that you're going to be delivering earlier now is going to be titled Technology and Climate Change. How can we use digital technology to save the planet? And I know this is a very favorite subject of yours, and I leave it in your good hands to take us forward. And after which we will look forward to also the panel that you'll be moderating, which I'll introduce separately later. Philip, in your hands. Thank you.
Thank you very much, Joe. And I hope everybody can hear me and see me and see my screen.
Yes, we can.
Excellent. The technology hasn't let us down, which is superb. Okay, I just want to start off by saying a little bit about what I do and the centres that I run. For the last 7 years, we've been working on how to decarbonise. We call it road freight, but actually it's all aspects of logistics. And at the end of the first 5 years, we concluded that we needed radical change. We weren't going to achieve this just by incremental change, and that would require all sorts of investment. And on the back of that, the UK government gave us another £12 million to carry on the research forward to 2024. And that's the phase of research that we're in now. So a lot of our work has been trying to explore and establish what does that radical change look like, and how will it impact the world that we live in now. And a starting point for all of that is sorry, I'm just working out how to maneuver my way around the slides as well, is to start thinking about climate change, and because that's going to drive the change. And 3 observations really that I want to make to set the tone for this. The first is that for the first time in our history, nature is looking like it could outpace our ability to develop technological solutions. And the implications of that are huge. We're not there yet, but the race, if you think of this as a race, it is very equally matched. Technology is just about keeping pace with the changes that is happening in nature. So we still have some time.
Philip, can I just say, you're not sharing screen. Did you have some charts you're presenting?
I do.
Yes, so your chart you are not sharing.
Okay, thank you very
Sorry
much.
For the interjection.
No, that's that's very important. I need to share the presentation. That one. Okay. Is that showing the screen?
That is now. If you can go to full screen, that's great. That's perfect.
Okay.
Perfect.
Is that all right now? As it's
That's very good. That's excellent.
Yes.
Thank you.
Okay. So fortunately there weren't many graphics in the first two slides, so you don't need to worry too much. You haven't missed anything. But nature is accelerating change, and we're struggling to keep up. Is the essence of the work we've done so far, and that means that there is no bigger imperative in the world at the moment than dealing with climate change. Everything else is secondary, because if we fail to address climate change, all the other challenges that we're facing become much more severe. So nearly every presentation I do these days starts with this 2 or 3 slides. This slide is showing a carbon budget. So this is what the scientists calculated back in 2010, the level of reductions that we would need to achieve if we were to stay below 2 degrees C global temperature rise. And you see it's quite a gradual, gentle slope. That was in 2010. But what happened in 2010 is the emissions started to increase and accelerate, get bigger, and they're still rising. And as a consequence of that, if you think about the area under this curve as being the carbon budget, then in order to stay within the same carbon budget, we have to accelerate the change, the decarbonisation. So we end up with a curve that looks something like that. And that means about a reduction of 80% in the next 5 to 10 years needs to be achieved. And that's very testing. If we carry on increasing our CO2 emissions, we will eventually, and when I say eventually, I mean in the next 5 years, reach a point where we have to go into negative emissions. That means we're taking out more CO2 than we're putting into the atmosphere. And we don't currently have a technological solution for that. So these are very testing times to be living in. And the steepness of this curve is really a good proxy for the amount of change that we're going to have to deliver in a short space of time. And at the heart of that is logistics and the supply chain. So how important is logistics? Well, logistics accounts for about 16 to 20% of total emissions. That includes all modes of transport and warehousing and factories. The demand for logistics is still increasing. And the way that we do logistics is getting more environmentally unfriendly. So lead times are shortening, which means that we are increasingly shipping stuff in smaller and smaller quantities, and we're using much more energy to do that. And despite that, we still have big inefficiencies in the logistics system. So worldwide, about 30% of road journeys are empty. That means the trucks don't have any useful logistics load on them. And of the trucks that are full, on average, they're about 60 to 70% full. Now, obviously, this changes from geography to geography, but overall, the story that we can take away from this is that logistics is a significant contributor to climate change. And if we're going to get down to net zero, which is the current target in the UK, then we will have to radically change logistics in the next 5 to 10 years. So let's put that into some sort of perspective. In maritime terms, where the lifetime of your assets is 15 to 20 years, that means that we're saddled with the technology we've currently got, if we bought it today, for a period beyond which we have to change things. Even in road freight, where the assets are relatively short-lived. We're talking about an asset lifetime in its first use of about 7 years, which means that for most operators, the next truck that they buy has to be something approaching to a net zero solution. So these are significant challenges that we have to face. The other dimension to this is that if we are to meet these challenges, then obviously we have to stop using carbon-based fuels, which means that the energy landscape has to change. And it already is. So we're using much more renewable energy. And because it is renewable, then in the medium term, the good news is that the energy inputs to whatever we do in terms of economic activity should be decreasing. But there's some infrastructure costs. If we're going to transform the energy system to provide clean energy to our logistics operations, then there is a big investment that needs to be made in infrastructure. And there are still some unanswered questions. For instance, who should pay for that infrastructure? I mean, it will ultimately work its way through to the consumer, but do the government fund it through taxation, or do companies carry the burden? And if so, where are they going to get their funds from? So we need to start thinking about how we calculate the value of net zero. So we need to get used to carbon accounting as a process that will become as ubiquitous as financial accounting. And I'm going to talk in a minute about how that will impact the investment landscape. So a little bit about costs. So we're already switching to renewables, and renewables will reduce the energy cost in the medium term. But renewables introduce a new energy dimension. And that is that if we use them, we have to find a way of storing the energy so that we can use it later. They aren't as tunable as the current energy generation facilities. So you can turn down your gas turbine quite easily. You can't turn down the wind or the waves or the sun. So if the energy is generated as electricity, which it generally is, then electricity has this peculiar phenomena. Well, it's not peculiar, it's what we all learnt in physics at school. And that is, if you generate the electron, you have to use it or store it straight away. So if we've got turbines, wind turbines that are turning, then that energy has to be used by something, or we have to find a way of storing that energy. And that is something we don't currently have to do. So storage is a big aspect of this new energy landscape. So what about the cost? Well, as I say, the operating costs will reduce, but the capital expenditure in the next 10, 15 years will outpace the operational expenditure benefits. So we all need to prepare to find new funds and attract investment to support our decarbonisation activity. And this is a lot of money. Okay, so for the UK, which is a relatively small island, quite advanced in its technology profile, we're talking about 1 trillion UK pounds. So, and that money has to be spent in a timely way. So over the next 10 years, £1 trillion of investment will flow into decarbonisation activity. And if we don't do that, then we will miss the opportunity to stop global warming going beyond 2 degrees C. And the consequences of that are almost too dire to contemplate. But in the UK, that has been made law. And if the government failed to deliver on it, then citizens can take them to court and prosecute the government for not fulfilling their obligations. And there is a high expectation in the UK that that will happen. It's already happened in the Netherlands, and that was a court case involving Shell. So financing the transition is quite complicated. We have a set of sustainability development goals. We have environmental, social, and governance scores. We have organizations with corporate social responsibility. And we have all those feed into funding pathways, whether that's from the private sources or from the government. And our hope is that that will deliver some form of sustainable competitive advantage to companies. Now, at the moment, all these things are pretty much operating independently. There's no real degrees of coordination across them. And organizations find this landscape quite difficult to navigate. So, how do we get this perfect alignment over the next 5 years around financing the transition? In other words, the alignment of national, international, corporate, and society goals that means the pathway to clear sustainable competitive advantage for organizations is increasingly clearer. And because it's increasingly clearer, organizations find it much easier to make that strategic investment and commitment. Well, it all turns on how we shape our organization. Well, it turns on two things, actually. It turns on how we shape our organizations, and it turns on how individual behavior starts to change. And this is, it's becoming increasingly apparent to me in our research, but also with the government departments that we deal with across the world, because our centre has representation in China, Africa, India, and the UK. So we're connected to regulators and governments in those geographies. Increasingly, the feedback we are starting to get, and it's relatively recent, those governments are starting to question how they change the behaviour of individuals. How do we stop people travelling so much? How do we get people to order goods that have been produced sustainably, or crops and food that has been grown locally? That is the question that people are starting to ask. And that impacts how organizations form the organization part of what they do. So we do need board level representation on sustainability in organizations. It's only when you have that board level accountability that organizations start to reshape themselves around performance measures that have been defined at the highest level in the business. And once we've got that board level representation, we need a clear sustainability strategy. So this is how an organization aligns itself to sustainable development goals and corporate, through its corporate social responsibility agenda. And I can give you just a quick example of this. dealing with a major retailer in the UK who's trying to make a decision about what fuel they should put in their trucks to deliver goods to their retail outlets and their warehouses. They have 3 options available to them at the moment, and all of them have a different timeline. The shortest solution is to use hydrogenated vegetable oil, palm oil, which is then processed and combined with hydrogen to make a replacement for diesel that is a direct replacement. The second is to wait a bit longer and use battery-powered vehicles. And the third option is to wait a bit longer again and use hydrogen fuel-celled vehicles. Now, from a scientific perspective, 2 of those options are unattractive. They are the ones that involve hydrogen. And I realise this might be a bit controversial. Maybe there will be some questions that come up later on. They are unattractive because hydrogen takes a lot of energy in its production process. Almost 3 times as much energy compared to if you use the same inputs to generate electricity and power a battery-powered vehicle directly. So anything that uses hydrogen is actually energy inefficient, but also in the current environment where we are producing hydrogen using steam methane reforming, it produces a lot more CO2. Now, this organisation has struggled with this decision for 2 years, and they've only recently made the decision that they won't be using hydrogenated vegetable oil or hydrogen fuel cells because they fear that that would have a negative impact on their corporate social responsibility reporting. And that in turn would lower their environmental sustainability goal score, which would reduce institutional investment in their organization and make them uncompetitive. So despite the fact that we've been struggling with climate change for seriously for a decade and a bit, organizations are only now starting to get to grips with how they align their policies with government's policies and international strategies or goals to deliver shareholder value. And that's the important thing here. We also then need to think about how we mobilize the strategy within the organization. So how we get full depth penetration of these decarbonisation strategies into an organization. So are there any mantras, any rules that we can start to develop that are valuable to organizations that they can start to incorporate into their strategic thinking? Well, and at the same time, deliver some sort of competitive advantage and thereby increase profitability. It's certainly true that we can reduce waste by improving the connection between supply and demand. And that's something we've been teaching in supply chain theory for some time. The quicker we make the connection between demand and supply, the less inventory we have to store in the supply chain, the less it costs us, and the less waste we produce. So improving connection is about speed of data. And so increasing the speed of data will give us some commercial advantage and give us some environmental improvement in our environmental performance. so environmental benefit. The faster we can move things through the supply chain, also reduce waste. But I'm thinking here in particular of food chains. So the faster we can move things from production through to consumption, then the less likely it is we will incur waste in the processes that are currently on that journey. We can reduce waste by maximizing product life. So this is about servitization. You could argue this is also about the circular economy. We should be designing things that can be recycled and be reused and remanufactured and cannibalized, not that go into landfill as waste at the end of a very short life, because the pressures of competition means that we are constantly trying to innovate and increase the speed of innovation around our products. And that means that they become obsolete faster now than they have ever done in industrial history. So if we modularize our design so that bits can be stripped out of it and reused, and we put diagnostics into our products so that we know the status of the product when it reaches the end of its first life, which bits can be reused, cannibalized, repurposed, or remanufactured. That is again a technology component to our products that is not implemented in a widespread way at the moment. And creating more value from the circular economy will improve its efficiency and increase its attractiveness. So I want to end now just on a quick run through of what that might look like in an application that is now. When I first started showing this, it wasn't actually implemented, but now has been implemented in the real world. And here we've got a virtual fridge, a fridge that is internet connected. And it has been designed so that it has some diagnostics on the fridge. So it can tell that the pump on the refrigeration unit is starting to fail. We know how to do this. If you get unexpected vibration profiles from a pump, then we know that is probably occurring because of bearings failing or some other components. So we know how to differentiate the signature, the vibration signature of a good performing fridge from a bad performing fridge. And once it recognizes this, that it's about to fail, it hasn't failed yet, but once it recognizes that it is about to fail, it can transmit a signal to the internet. It could also transmit that signal to other fridges, and those other fridges can report their status, and they might be local to the first fridge. And one of them says, well, yeah, so the pump on my fridge is also failing. Receiving that same information is a factory that says, well, I've got 3 pumps. I can see a demand for 2 pumps. Okay. And some sort of service provider who says, well, I've got a delivery, it might be groceries or clothes or whatever, that is going to the first fridge's destination. So that service provider then says, well, I can actually, whilst I'm visiting the first destination where we know the pump is failing, I can go to the other destination where there appears to be a faulty pump, and I can replace that one. But importantly, it could also say, well, my analysis shows that even though we've had no failure signal from the third fridge, I could replace that at the same time because I'm in the vicinity, and that would be preventative maintenance. Okay, and at the same time that the factory commits to delivering 3 pumps to this local area, the upstream supply chain trips into action and starts making the replacements. So Sorry, just go back to that slide. So the story here is that by introducing technology into our product design, we can build connectivity, and we can use that connectivity to leverage modular design so that we can do preventative maintenance, and we can reduce the effort of servicing those needs, all because data is traveling faster and further in the supply network now, as opposed to the supply chain. So, in summary, climate change demands a new energy landscape. This demands a massive upfront investment. So there's going to be a lot of money being pumped into this new energy landscape. And inevitably, that will create opportunities. And we know, because people are starting to leverage technology, that technology itself will play a key role in transforming logistics and decarbonisation, not just in the example I gave you there, but also in developing coordination platforms so that the logistics can be made more efficient. And on that note, and more or less on time, I think, I'd like to finish and hand back to somebody who is in more control than me.
Thank you very much, Professor Green. This was really very inspiring presentation. You're preaching to converted, but I have two questions to ask you, which is not normally done to a keynote speaker, but I know that you will like these two questions. The first question is, on the 4 action points that you highlighted, isn't there a 5th one as well? It's about localizing manufacturing or localizing nearshoring manufacturing, which could also be an alternative to reducing waste, reducing unnecessary flows, and basically reducing the amount of CO2 footprint. Is that not a consideration that you've done in your research?
Yes. So, and in some sectors, it is more obvious than in others. So in food, for instance, it is clear that reduction in food miles is beneficial. So local for local, as you would call it, is a good idea. But as has always been the case in supply chains, it's the value of the product as well, and how you balance economies of scale. So if there is a small local demand, then it doesn't make sense to actually sort of move it to a local manufacturing unless the technology allows you to gain some other benefits that compensate you for losing the scale efficiencies. So it's a bit more nuanced than just local for local applies to everything. I think it's about finding that sweet spot. Everything in logistics and supply chains is a trade-off. Everything. Sure,
absolutely right. Absolutely, good point.
And you've got to find that sweet spot. Sometimes it's more obvious than other occasions.
Yeah. So the last example you gave about IoT and diagnostics and managing the supply chain is excellent. But isn't there here a problem of mindset where over the last 50 years, probably, built-in obsolescence has been dominant in every single product we use? And therefore, what you are suggesting in item number 3, where you are looking at maximizing product life and even adding value by diagnostic through IoT, isn't that again going to conflict the philosophy of consumerism, of built-in obsolescence, and creating basically a direct collision with the whole philosophy of manufacturing?
So I think that's a good question. And 2 years ago, I would have said that's absolutely right. Yeah. But I think what's changing is the desire of institutional investors to invest in sustainability.
Right.
And so this is where the argument switches to shareholder value. So most of these organizations that have built in obsolescence into their products are now being challenged by the investor community to reduce that obsolescence and create value in other ways. And if they don't, they are being they're finding it harder to raise funds from those institutions. Now, I'm not saying it's a perfect world yet, and all the answers have been provided, but there is certainly a trajectory that it is now much easier to raise money for sustainable businesses than it is for non-sustainable businesses. And you just need to look at the petrochemical business itself. That's difficult to raise investment around internationally.
Sure. Thank you for answering those questions, Professor Greening. I think it's really important that we pass this message. I'd like to leave it there for the moment. I know you're coming back to the panel later on. I've just taken 5 minutes of our next speaker's time. So thank you again for your presentation. It was excellent insights, and we will pick it up on the next panel discussion. So